Chapter 3, Exercise 12. Assume that f and g are functions and show that f is a subset of g if and only if the domain of f is a subset of the domain of g, and for all x in the domain of f of x is equal to g of x. Right, so just the usual biconditional proof. We're going to prove that this implies that, and that implies this. So let's get started. So f subset g. Now let's suppose x comma y is an element of f. Now recall that functions are single-valued relations, so they must contain ordered pairs exclusively, and those ordered pairs must be single-valued. That is, this x is exclusively paired with this y. That y isn't necessarily paired exclusively with x, but the x definitely only has one partner. Right, so what now? Since f is a subset of g, x comma y has to be in g as well. So x has to be, okay, right, so before I do that, we're going to show this first, and then we're going to show this next. Okay, so note that if x comma y is in f, then x is in the domain of f, and then similarly, as x comma y is in g. Oh, fuck. Let's start over. Chapter 3, Exercise 12. Assume that f and g are functions and show that f is a subset of g if and only if the domain of f is a subset of the domain of g, and for all x in the domain of f of x is equal to g of x. This is a pretty straightforward biconditional proof. We're going to show that the left-hand side implies the right-hand side, and the right-hand side implies the left-hand side right back. So let's do the one side of the forwards direction. That's what I was looking for. And let's assume f is a subset of g. And then we're going to prove both of these hold. Now suppose x is in the domain of f. Then there must exist some y in the union of f such that x comma y is in f. Now, as x comma y is in f, x comma y must be in g as well. Why? Because f is a subset of g by assumption. Thus, there exists some y in the union of g, or rather, before that, thus x is in the union of g, and y is in the union of g. So x is in the union of g, and there exists some y in the union of g, such that x comma y is an element of g. Thus, x must be in the domain of g. And it follows that the domain of f is a subset of the domain of g. Right? Cool. So we got one of the two statements proved. And now we're going to show that for all x in the domain of f of x is equal to the g of x. So now, suppose x is in the domain of f. This is like part 2, if you will. Maybe add like a little line break here. Why not? Suppose x is in the domain of f. Then there exists some y in the union of f such that x comma y is in f. This implies, or rather, f being a subset of G implies that x comma y is an element of G2. In other words, G of x is equal to y. Now we could have done this in the above part of the proof, but I like to keep things separate. So yeah. And now note that this y is unique since f and g are functions. Okay, so we got this down, we got that down. So we have the forwards direction of this proof done. Now let's add a new page and work on the backwards direction. Now let's assume that the domain of f is a subset of the domain of G, and that for all x in the domain of f, is this how they wrote it? Right. F of x is equal to G of x. Right, now suppose x comma y is an f, then x has to be in the domain of f. Thus, or rather, since the domain of f is a subset of the domain of G, x must be in the domain of G. Okay, now what? So there exists some y in the union of G such that f of x, x comma y, I'm going to call this yg just to keep it general. It doesn't necessarily have to be, at this point, doesn't necessarily have to be equal to the other y, but we're going to show that it is indeed equal to the other y. X comma yg is in G. Now, since x comma y is in f, f of x is equal to y. We also know that for all x in the domain of f, f of x is equal to g of x. So f of x, which is equal to y, is equal to g of x, which is equal to y sub g. Thus y and this other y sub g have to be the same y. In other words, x comma y is in G, and thus it follows that F is a subset of G. Since we picked out an element from F and showed that it must be in G as well. And there you have it. That is all of exercise 12. Pretty short. It looked a lot more difficult than it ended up being. That's a good thing, I think. I hope this was helpful, and I'll see you in the next video. Bye-bye.